Hi. Hello, fellow array enthusiasts. Believe me, if you aren't one now, you will be very soon. Hi, I'm Erin McKean. I am an array enthusiast. I'm also a developer advocate for IBM, and I run wordnik.com. And I always like to preface any technical talk I give with this plea. I am a community-taught developer. I like to say community-taught instead of self-taught because I didn't like introspect Node from first principles. I learned it by the generosity of the community that writes tutorials and documentation. But if I get something wrong, please tell me, preferably after the talk. But please tell me, if not for me, then for my future audiences, because I always like to learn about how I can do things better, and it would really help me a lot if you would do that. So this is a talk that is aimed, according to the schedule, at beginners. But my goal for this talk is that everyone will walk away knowing something about arrays that they didn't know before, and with any luck, that something will save you several hours of debugging sometime in the not-so-distant future. And if you don't learn anything about arrays, I hope that you learn at least something about anything during this talk, because really, knowledge is a joy in itself, a pleasure in itself, and any kind of learning, I think, is worthwhile. And also, I do want to warn you about something. Something you hear about today, maybe in this talk, maybe in another talk, you will hear a lot more over the next couple weeks. And it is not because all of a sudden the universe is conspiring to make you think about arrays. It is because of the frequency illusion. Sometimes it freaks people out when this happens, but I just want to reassure you that this is totally normal. It's something your brain does to you. You can't do anything about it. Sometimes this is also called the Baader-Meinhof phenomenon. And now that I've told you Baader-Meinhof phenomenon, that term is also going to come up for you sometime in the next couple weeks. Anyway, let's talk about arrays. So what is an array? So array has a very technical computer science-y meaning, but unfortunately, that's not the kind of array that JavaScript has. You can always trust Douglas Crockford to be like, yeah, no, about technical JavaScript issues. So JavaScript doesn't really have a linear allocation of memory that's a very fast data structure and so on and so forth. But what does it have? It has a global object used in the construction of arrays, which are high-level list-like objects. And I think the first couple times I read that, that didn't actually say anything to me. So instead, what I like to think of is I like to think that arrays are objects wearing array hats. So sure, they're objects, but they're wearing an array costume. They're wearing the methods and the functions of an arrays. And I also like to think about arrays and their little, I like to think about objects and their little array hats. And also, it's a reference to community. But, so, how can you tell if something is an array if it's really an object? Well, actually, arrays are kind of no help. Because if you ask them what they are, what type they are, they say, hey, I'm an object. Because they really are objects. They're just wearing array hats. So you should use is array instead. And in that case, you will get the answer that you think you should be getting. Creating arrays, there's way too many ways to create an array in JavaScript. So you can use the literal way, just those empty brackets, then you get an array. And the important really thing about arrayness is that arrays have length. And once you create one, even though there's nothing in it, obviously it has a length of 0. So I'm trying this new Jupyter Notebook thing, that all this code is real and running. And does it need to be bigger? Anybody in the back, bigger? Raise your hand if you think it should be bigger. OK, let's give that a shot. That good? Good, thank you. All right, yes? OK. Just one more check, is it OK? In the back? Thank you. OK, and in ES6, we have a new way to make arrays. This is a very long string. It is the first line of A Tale of Two Cities. You're just going to have to trust me that it's the whole quote. Actually, you won't have to trust me, because there it is, split into an array. It's super long. But it's a really convenient way to make an array from a string. We also have the spread operator, which does the same thing. And there is, of course, using just new array. And if you're trying to make a new array from a string, it works kind of the way that you expect it to work. Hey, we've got an array. It's got A in it. That's great. Here's the gotcha. If you use new array with an integer or something integer-y, then this is what you get. That is probably not what you were expecting. So, however, ES6 gives us another helpful way to get around that if you really want an array that is just a single integer, you can use array.of. So that is the first gotcha. I think it's a pretty good one. As JavaScript gotchas go, that's definitely in the top 20. So once you have an array, you might also want to know how long it is. And so your array length is the index of the last array element plus 1. OK, so does everybody know about Northern English dialectical words for counting sheep? No? This is a fantastic Wikipedia page that will make your life so much better. So it turns out that there are different ways of counting sheep all across England, and each region has their own way of counting sheep, and this is one of my favorites: yan, tan, tethra, methra, pip. It's fun to say. If you are a super bored shepherd who has to count sheep all day, you're going to make it fun. Anyway, I'm super tired of examples that just use integers because I'm pretty sure everybody mastered integer counting by the time they were like 6 or 7 years old. So when I make examples, I like to have them be weird stuff that might teach you something more than, say, simple arithmetic. So now you know how to count sheep in, I think, Yorkshire. Anyway, you'll have to check the Wikipedia page just to be sure. So, small digression. You can add length to an array just by increasing the length, just like that. But it doesn't really actually add you the next thing in the counting sheep sequence, unfortunately. And it will lie to you. If you ask it how long it is, it will say, hey, there are 6 slots in this array, but one of those slots doesn't have any data in it. It's just null. But, OK, I'm very, very sorry to have to tell you this, but if you need to have an array that is more than 4.29 billion items long, you are SOL in JavaScript. You can't do it. Sorry, invalid array length. So that's the biggest array that you can have, is 1 less than that number. Seriously. Sir, if you have an array of 4.29 billion items, my hat is off to you. Like, good job. Also, your array can't be negative. I spent a lot of time trying to think of a use case in which I wanted an array that was like negative items long, and I could only think of like the Upside Down Land and Stranger Things. And I'm sure that they have negatively indexed arrays, but I do not, and neither does anyone else using JavaScript. You also can't have decimally indexed arrays. That's also invalid. I wish that if you had a decimally indexed array, it just took like, 0.1416 characters of the last item, but it doesn't do that either. That is not something that you can have. Of course, you can truncate an array just by changing the length. If you can make it longer by adding, you can make it shorter by taking something away. So poor Pip, our last sheep, lost. But deleting an item in the array does not shorten the array. So we took out tan from yan, tan, tethra, methra, but it didn't shorten the array. It just added a null in that space where we took the item out. So we just saw that you can delete an array item at its index. But there are better and cooler and funner, I can say funner, I'm a language professional, ways to do that. You can always just do the reverse of delete, right? Add something at the index. Hey, we've got tan back. You can also shift to remove something from the front of an array. And it'll return what you removed, and then if it's more than one thing. You get basically, shift takes the first thing off the front of the array, the 0 indexed. Pop does the same thing, except from the end. We are losing sheep at a constant rate here. Unshift lets you put that item or any item you want back at the front of the array, and it returns the new length of the array. So shift and pop, they return what you took off. Unshift returns the new length of the array. And push, I'm sure you all figured out a step ahead of me what push does. Push puts things at the end of the array, and it returns the new length of the array. If you use shift or pop on empty arrays, you get nothing, because there's nothing to give you. If you want to be more precise about where you're putting and taking your items, you can use Splice. So here at Splice, we are saying that we are going to take one item from position 1 out of the counting sheep array. And so that returns what was taken away. And as you can see, it doesn't leave a null. It closes up that hole nicely. And if you want to say, add something, here we're going to say at position 1. We're not going to take something out, there's no 0, but we're going to add. And there we go, we've got all our sheep back. And you can use a negative index to splice from the end. You can shove arrays together with concat. Yes, the counting sheep sequence goes on. The next ones in the sequence are Sethra, Lethra, Hovera. So if we have lots of sheep, we can shove our 2 sheep arrays together. If you want to, say, call all your sheep in one big shout, you can turn your array into a string, and then you've got a string. You can do this also with join. And join has another option where you can change what separator you want to be the joins between your array items into the string. So that gives us space, a little bit more readable. We can join with a comma and space. If you have empty slots in your array and you join it, then you're going to see nulls, string nulls, in the space where they're gone. You just get an empty slot. Extending arrays, copy within is a new thing in ES6, and I really like it. It seems like it would be useful, although I haven't done very much other than play around with it. So here, with copy within, we're taking our laugh array, and we're saying take 2 items, starting at index 0, and add them, basically. And these copy within will overwrite, not extend. So keep that in mind. You can fill arrays really quickly with ES6. So here, we're actually using that new array syntax. We want that behavior where we give it an integer and we want it to create an array of that length. And with fill, we can fill the whole array with whatever we want. So now that we have all of our arrays, we might want to be doing things with the items inside the arrays. So there's a new array find method. Use find when you want to find the result of a function. So I've created an array in the background that has a random selection of words from that Tale of Two Cities quote. And it re-randomizes every time I run this deck, so I don't really know what's in there. So I want to return the first word in that array that begins with the letter W. Okay, it's was. That makes sense for the first line of Tale of Two Cities. If I just want to know at what point in that random index is the item that satisfies that function, I can use find index. Oh, no, hey, it's the second thing. If we just want to know whether there's any item in our array that meets that test, we can use some. So yes, there is some word in that quote that begins with the letter W. If we want to make sure that every item in our array passes our test, then we use every. And unfortunately, not every word in that quote begins with a W, so now we're going to get a false. So here's a kind of weird, tricky thing. If you add an item during the time that your test function is running, tough luck. Find index, sum, and every will not find it. So you can see that here. We've got an array that's just 1, 2, 3. Sorry for the arithmetic. And as we run this sum method, our internal function, let's see what happens. So the first time through, we've got 1, 2, 3. We're going to push a new item. And then we're going to check to see if the item is 4. So we've got 4 here at the end of the array, but because we changed it during the running of sum, it's false. So think about this if you are adding data continuously to an array and you're trying to run a find function at the same time. It will not work the way that you are thinking it will work. If you change an item before find index, sum, or every get to it, it will check that value at the time that the item is visited. So let's see how that works. So you can see here, we are, first we'll log it. And we want to check to see if any of these items equals 2. But unfortunately, before we do this check, we've changed the item that equals 2 to be 0. And because it changed before it was visited, because sum looks at every item in sequence, it's never going to fulfill our condition, and we're going to see false again. So tampering with your arrays while you're running a find-like function over them is tricky. So keep that in mind. If you already know what element you want, if you just have a flat value or something that's pretty simple to evaluate, not a function, you can just use index of to give you the index of that item. And it will return -1 if that doesn't exist in your array. So Charles Dickens, unfortunately, did not have the word whatevs at his disposal. I'm sure he would have enjoyed it. But if you're trying to find something that's not a number, index of will not find it, even though we can see very clearly it's there in our not a number array. But find index will find it. So now we can see that our not a number that we're trying to find is at space 1. You can give index of an index to start at. And so here, because worst is the 9th element in that quote, it won't be found. So we're starting looking for worst at item 10. Worst is number 9. It won't be found. If you give that index a number that is greater than the length of the array will not be searched for your item. So that quote has 120 words in it, or 115. Oh, I guess it got modified. Then it's not going to find it because you've said stop. You've said start searching after my array is over, so it won't search at all. You can use negative indexes as an offset from the end of the array. But in that case, if your negative index is greater than the length of the array in the other direction, the whole array will be searched. So you can think of the array as like a number line going off in all directions, and if you give it a positive number after the end of the array, it starts there and it won't search. But if you give it a negative number before the start of the array, it keeps on going and it'll search through. My math teacher in 5th grade said the number line would come in handy for me someday, and I really feel like I should write her a letter and thank her because that's basically the first time. So last index of is just like index of, but it searches from the end. So you can say we have was at position 1 and also at position 90. If the negative index of last of, it's kind of the reverse of index of. So if the negative index is greater than the length of the array won't be searched because remember we're going backwards this time. So you've told it to start off the end of the front. If you just want to know if your array includes an element, but you don't care where it is, then you can use includes. So my random array does not include the word heaven from the Tale of Two Cities quote. So you can use filter when you want a new array consisting just of elements that match your function. So let's find all of the words in that quote that begin with the word W. there they are. And of course, if you want to sort them, you can use sort. Very clear. Does what it says on the box, except, watch out, sort is sorted according to string Unicode code points. Everybody's got that sort order memorized, right? Raise your hand if you've memorized that sort order. Which looks like this, which is kind of weird to how we think that things should sort. And I am actually a real live dictionary editor. This is called lexicographic sort. I can tell you as a lexicographer, this is not how we sort things. So I don't know why they call it lexicographic sort. Basically, the 10 comes before the 2 because it has 2 points, and capital letters come before lowercase letters. If you want to get arrays of unique elements, before you probably wanted to use a module like Lodash to do something like this, but the new set object in ES6 makes this a lot easier. You can just array from a new set of your array, and since set is unique, then you get your unique items. You can also use the spread operator to do this, get the same result. Reversing an array is pretty simple with reverse. Does what it says on the box. Okay, so I was told supposedly that reversing a string is something people are asked to do in interviews all the time, so here's how to do it. This is a lot easier now. I think when people were being asked to reverse strings in interviews, it was harder, but now JavaScript makes it very simple. Iterating. So we've seen a little bit of iterating with the sum and the everys. Those are all kinds of iterations, but they're kind of implicit iterations, and we might want to do explicit iterations. I love array for each. It means I will never have to write out I equals 0, I plus plus again, or I minus minus, whatever. I don't enjoy it. I don't advise it. Don't do it. Array for each is your friend. If you want to do something like this. So here we're going to get the length of all of our unique words. But remember, for each doesn't actually return anything. It just kind of goes through. So you can't assign the result of your for each to anything. You get undefined. Map is also awesome. Map is probably one of the top 3 reasons to use an array. It's just really fun. So what map does is it creates a new array. So it actually does return something, unlike for each. So the difference, if you're trying to think, should I use for each or should I use map, think about, am I just doing something with the output of the for each, or do I really want a whole new array? And map will give you a new array by applying your function to each member of your old array. So here we're going to capitalize all those unique words. Now we have a new array, the CapWords array. Reduce smushes an array to a single value using a function of your choice. It took me a really long time to find an example for this that was not mathematical in nature, but just adding numbers is super boring. So what this function does is it's going to return to me the longest word in that capitalized word array. So what it's going to say is, the reduce function takes an accumulator and a current value. So the accumulator is the last value that you had. And when you're starting from 0, it's the first thing in the array. It's going to say, OK, if that's longer than the current value, which is the next item, then return the accumulator. If not, return the current value. I generally tend to avoid ternary operators, this question mark colon thing, because I feel like sometimes they're very difficult to reason through. But this is a decent place to use a ternary operator because you're just trying to do one simple comparison. So let's see how it works. So the longest item in CapWords is the word wisdom. You can also have reduce right, which smushes your array starting from the other end. But obviously, the longest word in an array is going to be the same no matter which end you start at. So I'm going to leave that as an exercise for all of you to accomplish later. There's also the for in iteration, and it's just weird. And why is it weird? It's weird for 2 reasons. One is that it doesn't guarantee any kind of order that it goes through your array in. You would think it would start at 0, go through to the end, and then stop. But it will iterate through everything in your array, including non-integer keys. So let's just say that somebody decided to mess with the array prototype and just added a weird function to it, and you didn't know that, and you used for in, it's also going to show you that as one of the keys of the array. So that is super weird as far as I can tell. So for in does two things, and one of them I haven't shown you, which is it can show things in weird order. It might be insertion order, it might be array order, but you can't tell. It's an implementation detail, is what the documents say. So it kind of depends on what engine you're using. And then also, whatever it inherits, it will iterate through. So instead, you can do cool things with entries and keys. So for each, which we saw a few slides back, it doesn't, oh, I left out a semicolon. That's very unlike me. For each doesn't operate on null values. So you can see here, we have a hole where the 2 should be. And when we console log each item, we don't even get a null there. We just don't get anything. But entries will operate on null items. So here we can say what entries give you is they give you the key and the value. So you can see here at 1, we see that null. Object keys also doesn't like holes in your array. So you can see here we don't get the key for that null item. It skips right from 0 to 2. But the keys method will. So you can see here we get the keys even for null or missing items. Values works the same way, but it's not supported in Chrome, so I can't show it to you in the browser. So basically, entries gives you the key and the value, so 0, 1, 1, null. Keys gives you just the keys, and values gives you just the values. I do not know why we have keys and entries, but not values. Go figure. So I haven't talked at all about the biggest gotcha of all when dealing with arrays, especially with some of these new ES6 functions, and that is performance. There's a lot of discussion now about which of these methods are performant and which are not, and in what circumstances and under what conditions. And I'm not sure that it actually makes sense to talk about performance in a vacuum, because you have to decide what's the most important performance for you. Do you need to write very fast performant code, or do you need to have very fast performant developers? Do you need to optimize for understanding and ease of writing, or do you need to optimize for the machine? And that's a business decision that you have to make for yourself. But it's definitely something that you should check out and is far beyond the scope of this talk, unfortunately. So there's plenty more. This is the phone camera slide. There's so much to read about arrays. All of these sources are great. The MDN web doc should probably be your first stop. I know it is always mine. But especially Practical Modern JavaScript and Exploring ES6 are great for some of these new methods and functions. So, also, if you would like a Semicolon Appreciation Society sticker, please come see me at the end of this talk. I will also be at the IBM booth, at the booth crawl tonight, and at the booth tomorrow morning. I like the semicolon. However, you can appreciate the semicolon from whatever distance you deem appropriate. If you don't like them in your code, perfectly great not to have them in your code, as long as you appreciate their essential good nature. So thank you very much. You can reach me on Twitter. That's my GitHub. I will be putting this Jupyter notebook. It's up on GitHub right now if you would like to see these examples and play with them yourself. All this code is editable and runnable. You may have to do some tweaking to your Jupyter environment to get it to run Node, because really it likes Python and R as a first-class citizens, but it's pretty easy to run Node in your Jupyter notebook. So thanks so much for your kind attention. I hope you have a great conference.